Hey everyone, welcome back. And in this brand new course, we'll be talking a bit about GitHub Actions, continuous integration and continuous deployment, why that is important, and how you can set up these basic pipelines for your project on GitHub Actions. Now, by the end of this course, you would not just be able to understand what GitHub Actions is and what cicd is, but also would have built your few small build pipelines where your project is being built, is tested, and then deployed automatically wherever you want. So let's just go ahead and get started with this mini course which we have on CodeDam, and this is part of your full stack and backend learning paths on CodeDam. So make sure you are subscribed to CodeDam if you are not yet, because we'll have a lot more things to follow up after the CI/CD course. Let's go. All right, so in this course, I'll be following up with a simple React playground. I'm just gonna say CI/CD with GitHub as the name, and you can pretty much follow along on your local system or on CodeDam playgrounds on codedam.com/playgrounds. And once you get started with the project, what we'll be doing is not focus on the project that much, but focus on something known as YAML files in this little series and GitHub Actions eventually. So let's talk a little bit about GitHub Actions as well. So GitHub Actions is basically a service which allows you to do continuous integration and continuous deployment. Now let's actually understand what this exactly is and why do we need these kind of things. Well, you see, when you're building a project like on CodeDam playgrounds or on your local systems, what you are essentially doing is working in the best possible and the best comfortable way you can as a developer, right? So you are working on all of this code and folders and everything as a nice experience for yourself. But a lot of times your project actually needs a build step and sometimes even a compilation step to become production ready. That means trimming off unrequired code, compressing the code, making the code more performant, and so on. And all of this build step and compilation step takes time to run. So what these CI/CD services do is in a nutshell, basically they allow everything which you have coded or written, or any member of your team has coded or written, build and deploy on staging, production, or preview environment, whatever environment you have, automatically once you push on a repository like GitHub. Now, this is again important because you don't want, as a developer, you don't want to spend a lot of time just building and testing all the things by yourself on your local system. Why? Because it wastes your time and it wastes the capacity of compute you have on your system. So you want to make sure that your deployment and testing part is as much automated as possible so that you as a developer spend most of the time working on logic and building new features instead of actually building the project itself and testing it yourself. GitHub provides this as one of the services, but GitHub is not the only place where you can run CI/CD. There are basically countless tools out there which can do that. But we prefer GitHub. I prefer GitHub in this one because GitHub Actions actually sits right across your source code, right? So when we will take a look at how we push this project to GitHub and so on, I'll actually show you that basically GitHub is just very convenient to push your source code to. So yeah, that's pretty much it for this video. I'm gonna see you in the next one really soon. Hey everyone, welcome back. And in this video, I want to talk a bit about YAML or YML, like I wrote here, and what this exactly is. So YAML stands for YAML is not a markup language, or sometimes some people say yet another markup language as well. But the point you have to remember is YAML is pretty much what JSON is, right? So you have seen stuff like package.json, right? So when you take a look inside package.json, you see there are these objects which can contain keys and values, right? YAML is pretty much the same thing. The only difference is how YAML is written. JSON is used as a thing to communicate between different kind of languages and build systems and environments, right? So package.json can be read by JavaScript as well. Package.json, this file technically could also be read by a Java program or a Python program, right? So let's say if your Node.js script wanted to spit out some data which your Python backend would read, then one way to do that is to spit out that data into a JSON format. Similarly, YAML is also a similar format for which you would have You would require a few libraries. For example, there is no native support for YAML in Node.js, but it's more like a data exchange format among different languages or different systems. Now, what YAML does better over JSON is readability, right? So we're gonna see eventually, like this is also quite readable, but YAML is even more cleaner. Why? Because it uses very less special characters. Like usually there is no need of these quotes, these brackets, these commas, nothing is required, right? There is very, very minimal language syntax which you need, and a lot of information which needs to go in the file is just basically what your logic is for the data. So in this little section, or in this collection of videos, we're gonna learn about YAML a bit, because it is really important to understand YAML first before you actually start writing workflow files, because this is almost like a new kind of data format which you're seeing, right? So yep, that's pretty much it for this video. Let me go ahead and get on with you with the YAML syntax a bit from the next one. Hey everyone, welcome back. And in this video, let's start with YAML basics, right? So we're going to cover a few important things in YAML. The first thing is how you generate keys and value pairs, right? So in YAML, what you do is you say key name and then a colon and then the value, whatever that value is, right? So this is like a completely valid YAML file. Similarly, let's say if I have a service, my codedam project, then I could have, tests or script as script 1, then test 2 as script 2, and so on. So what essentially we are doing here is, if you want to compare it with a JavaScript based rendering, something equivalent in JavaScript, let me just go ahead and actually create a basic.json file, because I don't want to destroy our package.json. So I'm going to go ahead and open this basic.json, and I'm going to try to convert whatever we have written into the JSON part, right? And the JSON equivalent of this would be something like service, then a quote, then test, then these quotes, and then test2, then this quotes, and then closing. And of course, these keys should also be in quotes, right? So this is a JSON file, and this right here is a YAML file. And you can already see that YAML has much more condensed information compared to JSON, right? And it just gets more condensed as we nest objects and as we go ahead and start working with that. So you can see right now that we just created some top level keys and value pairs. Now it is possible in YAML to also go ahead and create nested objects, right? And the way you do that is pretty much with indentation. So you can say my app as the key of a parent object, and for these 3 keys you have to indent them. Now this is very important in YAML, just like in Python, that these indentations are actually consistent with each other, right? Whether they are spaces or tabs doesn't matter, but they have to be consistent with each other, that if you're using one thing, then it has to be one thing all across your file. The similar logic in JSON would look something like this: my app, and then an object, something like this. And yep, there we go. So these 2 files over here are technically equivalent in terms of the data which they contain, right? So this is important because now you can see that it's much cleaner and much more human readable compared to JSON. So that's pretty much it for this video. I'm going to keep it short because I want you to understand how this YAML file looks like and works. And in the next video, we're going to be taking a look at how you can work with more data types in YAML. Hey everyone, welcome back. And in this video, let's just quickly take a look at comments in YAML. Now, one of the best things I like about YAML is the support of its native comments. So you can say this is my comment. And right here, this would pretty much be ignored by any file which is reading this particular piece of data, right? This is impossible in JSON. I mean, JSON does have some variants where it allows these comments over here, but you'll start seeing that comments are not permitted in JSON is something you will pretty much see every single language or library which does not have some additional functionalities would be complaining about, right? JSON cannot have comments. And this is one of the nice things about YAML, is that you can start it with a hash symbol and start leaving comments all the way across, right? You can leave comment over here, hello, you can leave comment, somewhere here. It doesn't matter. It just has to start with a hash symbol and it has to be like a single line, right? Whatever you write in front of that hash symbol would get commented out. There is no multi-line comment as far as I know in YAML. So most of the stuff you do can be done just with single line comments, which is, I think, is fine given that it's mostly organizing data and configuration and not actual code. So as far as that is concerned, that should be good. So yep, that's pretty much it for comments generation in YAML. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at lists in YAML and how that works out. Now, lists in YAML is basically a way of organizing elements in an array, right? So for example, you're going to have something like my array like this in JSON, and you can add something like this, right? This is like a valid JSON over here. The similar thing can be done in YAML as well, basically in the same format, right? So you can copy this and you can paste it right here. You just have to remove the extra stuff. And this is like completely valid YAML syntax over here. Now, the good thing about this YAML part is that there is another way to create an array of objects, and I'm going to tell you what that is. So let's say if you have this array as an array of objects, then you have something like key1, value 1, and then let's say key2, value 2, right? Let's say we have this particular JSON object and we want to create a array representation of this particular thing in the YAML world, right? So how would we do that? Now, the way we would do this particular conversion to this over here is as follows. Whenever you want to start a list of things in YAML, you press enter, give it a tab, or in this case, it would work without even a tab, and I'll tell you why. But the general rule is press enter, give it a tab, and put a dash. Now this dash over here signifies that, hey, this is a single element in this array, right? And when you do a structure like this, and when you start mentioning key value pairs, then YAML automatically knows that this is an object, right? If you wanted to replicate the earlier example of this into this newer format, what we will do is something like 1, then 2, then 3, then 4, then 5, then 6, right? This particular thing, which I have written, is pretty much equivalent to this thing. But the reason we used this syntax earlier is because it's much more cleaner and concise. This syntax would not work with array of objects because, well, you need multiple properties over there, right? So what we do is we start it with a single dash, and then we'll start mentioning the key value pairs. So I'm going to go ahead and take a look at here, and it says that key1, value 1. So I'm going to say key1, value 1, right? And actually, let me just go ahead and add a couple of more keys here. Key random and value random. Right now, in order to create this, I'm just going to give an enter and do this. You can see that I did not put a dash over here. Why? Because this is a single object, right? The moment I put a dash over here, this means that the new object has started in this case, right? So I can now go ahead and put key2, value 2, and I can go ahead and say key random 2, value random 2. And this would actually represent the following data over here inside of JSON, right? So I'm just giving you a JSON and YAML comparison just because it's easier, and most people have worked with JSON in the past. So it's easier to bring those learnings into the YAML world than actually just understanding everything from start, right? So you can see that it's much cleaner. This syntax already looks much cleaner to eyes compared to this one. And it gets even better as you have more and more things going on, right? But that's the essence of YAML in a nutshell. You can have numbers over here. That's completely possible. You can have booleans, you can have, strings, which we have already discussed. If you want, you can put them in quotes. That's also completely fine. This is also fine. And if you want, if you can just remove the quotes as well, that's also completely possible. So yep, that's pretty much it for this video. In the next one, we're going to discuss some more concepts on YAML and take a look at how, maybe things like multi-line strings or those sort of things would work out in YAML. And the good thing is there is support for that. So that's all for this one. I'm going to go ahead and see you in the next one. Hey everyone, welcome back. And I just wanted to make this quick little video. I just Googled YAML validator on Google and wanted to show you that YAML needs to be proper in order to be parsed, right? Because this CodeDam editor, although it does provide syntax highlighting, currently we don't tell you if the YAML is valid or not. So whatever YAML stuff you are writing here, you can go ahead and paste it inside this YAML lint. Click on go over here and you'll see that it gives you a valid YAML message, right? Now if I go ahead and mess around with the spacing a bit, you're gonna start seeing stuff where it says, you know, some sort of error sent something, and it also highlights the line number. I mean, I don't really have any clue about whether this website is the best one out there or not, but if you Google YAML validator, you should be able to find some nice little online website for the time being, which can help you with just validating YAML. And you can see it already says valid YAML, but if I give it a couple of spaces back, you can see that it starts messing around, right? So that's one thing I wanted to tell you, that YAML needs to be validated. It's not like you can mess around with spaces and padding all the time. So make sure whenever you are, just executing this configuration file, whether that's on GitHub Actions, whether that's on pretty much any other thing. And if I haven't told you yet, YAML is a very, very popular way of writing configuration files in a lot of DevOps and in a lot of infrastructure as a code stuff as well. So if you did not know that, then congratulations, you have been learning a markup language, which would be very, very convenient for you when you are getting into that space. But yeah, I mean, that's the whole point of this particular video. So yep, that's pretty much it for this one. I'm gonna see you in the next one really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at what YAML multi-line string is and how you can work with that. And this is also one of the interesting things about YAML, that is you can represent multi-line strings. That is not possible in the native JSON format. Again, second feature which we discovered and which we are talking about. The first one was comments. The second one is this multi-line feature. Okay, so let's say this value over here needed to be multi-line, right? Or let me just get rid of this because we already have discussed how the nested objects and array of objects work. So let's keep it a bit clean. Even this top level would work fine. So let's say if I wanted to have a similar thing over here in my JSON representation. Now the only way I can represent multi-lines in JSON is by actually physically typing the new line character. So I can say something like, my name is Mehul. I am 23 years old. I am the founder of CodeDam. Like these three lines, right? But in order to represent this new line, I have to write this new line character, right? I cannot give this an enter key. This would not work. JSON would complain. But this is pretty much possible in YAML world, right? Why? Because you can go ahead and start writing, my name is Mehul, hit enter, and give it a tab. I am 23 years old, hit enter, and I am the founder of CodeDam. Now this is fine, but when you copy paste or create a second key, hello world, let's say, and if you copy paste this in the YAML validator, now what happens if I bring the first line also in the next line, right? Now you can see that it starts saying me unable to parse. Now in order to tell this service key that, hey, you're gonna find a lot of multi-line content in the next line, you have to give it a pipe symbol over here. Now the moment you do that, you tell the YAML syntax that, hey, whatever you're writing over here is actually multi-lines, right? So until and unless you encounter another key or the end of the file, that is a string. So in order to make this valid, all we have to do is something like this. And this is now a multi-line string in YAML, which is the equivalent of what we have written here. And now you can see the application of YAML in the human readable stuff, right? So yep, that's pretty much it for this video. Hopefully you understood the basics, the fundamentals of YAML. This is probably more or less all we would need in order to understand and work with the GitHub Actions part. So let's get started with that now and deploy some pipelines on the GitHub Actions. I'm going to see you in the next video. Hey everyone, welcome back. And in this video, let's just go ahead and write our very first valid action in GitHub Actions. And this is kind of a hello world tutorial for GitHub Actions. So let's go ahead and take a look at how we can do that. So I'm going to go ahead and actually make some space over here because we don't need the terminals just yet. So what I'm going to go ahead and do is remove this, and let's just also remove the basic. We don't need it anymore. And we can start working with test.yml format itself. It does not really matter. And the very first thing what a GitHub action needs is a name, right? A name as the key. And let's say this is something like my first GitHub action, right? The second thing a GitHub action needs is when this particular action should run, right? Which is specified with this on keyword, right? And the reason you need to specify this particular thing is because there are many times you want to run a workflow file on sometimes like a push, on a commit push, or sometimes on a pull request when somebody creates a pull request on your repository, or something like on a deployment status. This action is basically, you can think about this in a way that, let's say you have a bot, like a Vercel bot, which deploys your project online and then sends you the URL of that particular project, right? Which is deployed. So you want this action to then run and maybe do whatever end-to-end testing it wants to do. But the most common and the most simple one is on push, because this says that, hey, whenever you push a commit, run this action, which is precisely what we want in this case. The next thing GitHub action needs to know is the jobs which it is supposed to do, right? The jobs which it is supposed to run in the single workflow. Now, one important thing about this jobs is that there could be multiple jobs. I'm specifying this as jobs, not a job, and I can start working in a fashion where I specify all the jobs over here. So let's say one of the jobs is to print hello world, right? This is a single job. And you can see that I'm trying to create an object within an object over here. It's not a list. So this means they're not running in sequential. This is very important that I have not put a dash over here. That means this is not a list. This is not an array. This is actually an object. That means there is no guarantee that this would run in sequence. If I have a second SECOND job, SECOND job, if I have a second job, then also it is not possible. It is not compulsory that these two jobs would run one after another, right? But let's stick to only a single job for now. And let me just go ahead and specify a couple of more keys. I'm going to say runs on Ubuntu latest, which is basically what the underlying image you want on the runner. And we'll discuss about that. Don't worry that much. And then finally, in a single job, you want to have multiple steps, right? Because in an ideal world scenario, this job would be something like, build my project. Then another job would be check linting, right? Another job could be unit testing, something like this, right? So what this would be, let's just rename it back to print hello world, because that's what we will be doing, is we want to specify an array of, steps again, because these steps should be executed in order. So I'm going to start creating an array over here, and I'm going to start saying run, and this run pretty much is the bash command over here, which you specify. So I can say something like echo, something like hello world, like this, right? So what essentially we have created is a very small GitHub action job, which runs this print hello world job on Ubuntu latest Docker image. And there's only one step in this case, that is to run hello world. I can specify another step, and I can say this is step number 2, and this is guaranteed. And don't worry about the syntax highlighting, which is breaking, but this should work technically. Let's not keep number 2 so that it does not break the tutorial, but this is step number 2, and it is guaranteed that these 2 steps would execute one after another, right? It is not guaranteed, or in fact, not even guaranteed. It does not even happen that if I have a second job over here, that these jobs would run in sequence, right? Like I mentioned earlier. So anyway, we have a working job right now with us. Let's just go ahead and try to push it. So I'm going to say added a new job, hit enter, and I'm going to push this to the master repo. All right. So once that is pushed, I can go ahead and copy this repo over here and open this in a new tab. And what we'll see the first thing you will see is now you have this nice little yellow dot over here in your repositories, which on clicking shows that, hey, GitHub is running your action. Now you go to Actions tab and you can see that there is another added a new job workflow which is running over here and which has already ran and completed. So the way you debug this and know more about this is when you click on this. But that is something I want to discuss in the next video. I want to keep these videos short and crisp. So hopefully you are able to build your first GitHub action with me over here. If yes, then that's a great thing. You have just started your journey on the CI/CD and just, removing a lot of headaches of testing and building and everything, just transferred it to GitHub. So congrats on that. But that's pretty much it for this video. I'm going to see you in the next one really soon. Hey everyone, welcome back. And in this video, let's just take a look at what this GitHub action did when it ran and how you can actually work with this page as well, because a lot of times you will be working with this page as well. So when you click on this page, and this layout might change maybe in future when GitHub updates their UI, but the fundamental concepts remain same. You can see that GitHub provides you with a bunch of options. The first thing is you can rerun these jobs, which are over here. When you click on this button, GitHub would run this action again. And this is helpful when sometimes your job fails. This whole workflow file fails because of some external reasons which are now fixed. For example, let's say Docker is down or AWS is down or something is down which led to your workflow failing. So you don't want to push another commit to trigger that workflow or do any sort of other action. You can just go ahead and click on this rerun all jobs button. The second thing over here is these three dots. You can see that over here they provide you with some very minimal information. You can view the workflow file which was executed. In this case, this is our YAML file which was executed. You can see the workflow runs which this has done, which brings us back to our actions tab, kind of more or less, because we only have a single action over here. And the third thing which you can see is that you can create those status badges, which people, often you might have seen often this is embedded on repositories, that build passing and test running and all that kind of stuff. So you can build those badges like this over here. Just copy this and paste it in your GitHub README files and you're good to go. So this is pretty awesome. These set of features are very handy sometimes when you need them, but the way you actually get into what has happened is you click on this step or click on this job, not the step. So what GitHub does is that it will organize all the jobs which you execute in this section over left. So you can see that if I specify another job, let's say this is print hello world 2, and if I add this and if I commit this job 2 and if I push this, git push origin master, you're gonna see the second action which gets run over here. This job 2 over here has these couple of jobs running, right? And again, they kind of appear in order, but they are not really executing sequentially, right? You can see that they started executing parallelly. So this is very, very important because this is an object. This is not a list. So GitHub follows that particular thing. But what you can see over here is that you can jump into a singular job by clicking on them. So now what this page over here does, it shows you the steps in all the jobs. Now you might be thinking that, hey, I did not specify the setup job and complete job steps. Then why are they here? Well, you see that GitHub, obviously, when you specify this runs on thing, obviously needs to set up that particular environment for you, right? In this case, you can see that because we specified Ubuntu latest, it gave me Ubuntu 20.0.3. You could have technically just hard coded your Ubuntu version here as well. And then GitHub would always give you that same environment, right? And you can go ahead and take a look at all these environment variables as well, right? GitHub token also gives you a glimpse into what is possible within your workflow over here, right? We're going to discuss a little bit about GitHub token later. Then once your environment is set up, your next steps start running in sequence. Again, this is in sequence. This is not happening parallelly, right? These two commands are not running parallelly. They are running in sequence. So hello world is executed first, and this is step number 2 is executed second. And then finally the job gets completed. GitHub does some cleanup of processes and this and that. You don't have to worry a lot about this, but this is in general what your job looks like. Then there was a similar but separate job running parallelly to this one. Jobs run parallelly, steps don't run parallelly. And this particular thing pretty much executed the same stuff which was happening, right, in the job one. So there's nothing really to explain here. But yep, that's pretty much it for this video. In the next one, I'll actually tell you how you can execute jobs in sequence as well, because that is also like an important part. But this should get you started with at least writing your first few bash scripts in GitHub Actions. Hey everyone, welcome back. And in this video, let's just go ahead and actually, instead of just jumping directly on how to make interdependent jobs, let's actually first of all try to build this project, which we have been trying to do since the very starting. So I'm going to go ahead and say this job as build app, and I'm going to keep this runs on Ubuntu latest step as intact, because this is something which we need. We're going to be going ahead and removing this particular thing, and we're going to be messing up with steps a bit. Now, the reason for this is that if you take a look over here, GitHub Actions at the end of the day, although it is integrated with GitHub closely, I mean, it's just a tab away, but still the environment which it prepares is completely isolated with your repository, right? This is a Docker container. This is a temporary environment running somewhere on the cloud which you don't know about. So obviously it does not have access to your repository right away, but GitHub has created some interesting and some handy actions, default action steps, which allow you to work with your repository easily, right? And we're going to be taking a look at all of them, most of them, and I'm going to show you how you can find them as well. But there is this one action which you can use called actions checkout version 2, right? Now, if you Google this string up, you're going to land up on a page like this. Now, if you pay close attention to the URL over here, it is github.com/actions/checkout. So this actions is actually an organization account from GitHub, which includes a lot of interesting and default runners, right? Or step, as you can say. So this checkout action over here, the only thing it is supposed to do is, clone the repository in which it's currently running. And of course, you can customize it with all sorts of options and all sorts of customizations. But the moment you specify this action, what it will do without any customization is that it will clone the currently running directory, right? So if I go back, and right here in the next step, I do something like run, and I say, let's say something like ls, for example, or not ls, let's run tree, right? Because tree would show you pretty much all the output which a particular directory has. This is a bash command, right? Nothing GitHub or nothing fancy like that. So if I go ahead and run this now, new action, and if I push this to master, you're going to see that when this action gets deployed and when this action starts running, if I go inside this build step, you can see sometimes it takes a couple of seconds to start the build process. But if you come here on time, you can also see how or what it is doing to initialize that particular action. Sometimes it gets lagged a little, but yeah, right here, you can see in the second step, it ran actions checkout version 2, and it had these bunch of steps. You can see it initialized it with a bunch of default values. This repository over here is of course the default repository because it was able to compute that particular thing where it is executing. And when we ran this tree command over here, you can see the output which we got was this. This means that our repository was successfully cloned, right? Because this is our repository over here. You can see the file structure. We have the src folder, we have the public folder, and this is exactly what we see in the runner. So at this point over here, we have the repository cloned. That means we can start building stuff, right? So yep, that's basically it in terms of setting up your repository on the GitHub runner. The only next thing you need to do is set up Node.js on this repository and start working on it. Start working on building your project. So I'm going to go ahead and tell you how to do that particular thing in the next video. That is all for this one. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this one, let's just go ahead and take a look at what should be done to set up Node.js on this repository right now and start building stuff. So of course, thankfully, there is another action which you can specify from GitHub itself, that is actions, and then set up, not the @ set up node version 2. Again, if you Google up this string, you're going to land up on this action over here, which the version 2 is a newer version, which allows you to set up a node with any sort of version you like, right? You can specify this with property over here. Let me just copy this, or let's just write it. So I'm going to specify this with property over here. I'm going to say that, hey, this right here over is node version, and then let's say 14, right? So let's see, there we go. So what this means is that, hey, I want node 14 cloned into my repository, right? Or if you wanted a specific version over here, let's say if you wanted 14.17.0 cloned, right? Then this 14.17.0 would be available in your environment. Now in the next step, you can just have something like node v, and you can just node setup. Once you push it, you're gonna see the moment GitHub Actions starts running it, it's gonna set up that particular node environment for you. All right, you can see if I expand this run node v section, you can see it ran the node v command and it gave us version 14.17.0, right? Which is exactly what we specified in our setup node area. So that's all fun and games, but how do we do anything from this? Well, when you install node version, it automatically comes with npm and yarn installed. So the next thing you can do is start working on building your project. Now the good thing about GitHub Actions is that you can also specify, or you can also change the name which appears here. Right now it just says run and then whatever command you are saying, but I can also specify that by saying name as the property instead of run directly as build the project. And then I can specify the second property in this array of object, that is the run thing. And now I can say, if I have a package.json, and if I, let's say, specify a build command, I can say snowpack build. And just to see if this is working, we can just run it here as well. And you can see snowpack build is in fact a command, and I'm just gonna remove that for now, but this should get us started, right? I have a yarn build command now, and I just have to say yarn build over here, right? And maybe the next step could be set a finish, and I can just say run echo hooray, right? So if I say multiple steps over here and push this to GitHub, what you're gonna see is now when you go to the actions tab, it starts with a multiple steps commit. We can go into the build app job, and right here we should see that it should build your project in the cicd runner for the first time, right? And of course this fails because you can see that it is not able to find snowpack. So can you guess what you have to do over here, what we did wrong? Well, we missed a step, which is that you have to install node modules, right? And to do that, all you have to do is just write yarn. That should be more than enough. And we can add a commit missing installing node modules step, right? Git push origin master, hit enter, go to GitHub, go to actions, go to the build area, and you should be able to see that GitHub now should be able to build your project successfully. As you can see now, it's starting to install node modules, and this is like a great place to be if you want to just take a look at how everything is working out, because GitHub gives you real-time logs of whatever is happening. And you can see now, if I expand this node modules area, we see the logs which were coming in. It built the project. That means it created this build directory over here, right? And the setup got finished and we got a hooray from GitHub Actions, right? So yep, this is pretty much it for this particular video. We have built a project, we have pushed our project to GitHub, and this just works out of the box, right? So yep, that's pretty much it for this one. We're gonna be exploring more on the deployment, testing, and development part in the next video. Hey everyone, welcome back. And in this video, I'm gonna go ahead and show you how you can deploy the simple React project on Vercel from GitHub Actions as the CI. Right now, Vercel does provide its own CI and the ability to do that, but sometimes it's not just enough. That means you might have to install a bunch of different things, or you might have to do a bunch of different testing, for example. So you might want to just say to Vercel that, hey, I want to run my own action as well, but you can, once it's done, maybe in this case, in React's case, it's simple because you get a bundle of static files, then you can go ahead and deploy it by yourself, right? So what I'm going to go ahead and do first of all is I'm going to go to git ignore and add and add build folder, and I'm going to run the yarn build command locally. And the reason I'm doing this is to show you why I would be writing the commands which I would be writing now. So you can see when I run yarn build, I can go to the build folder and we have this static output over here, right? So on Vercel, we would not be deploying this project as a React project, but in fact as a static HTML project, right? Because in that case, Vercel can just skip the build and deploy this directly. So what I want to do now is go inside the build folder and actually write the command vc, or before that, let me just go ahead and add vc, that is Vercel. I hope that's what they call their CLI tool, but if not, we can check that later. But once you add this Vercel package, you're gonna see over here in the package.json that Vercel should be available, and this Vercel package ships with a binary called vc. So I can say yarn space vc, hit enter, and you can see that it tells you to log into Vercel first, right? In my case, I'm gonna go ahead and use GitHub, right? So I'm just gonna go ahead and copy this particular URL over here, open this in new tab. And because I already have an account with Vercel, so it should just work right away. You can see I have this token with me. I copy it back, hit enter, and now my Vercel is connected, right? Now it says me to set up and deploy code, for which I'm just gonna reject for now, and that's that. So the next thing I'm gonna do is take a look and see that we still don't have any Vercel configuration. So what we can do is we can say Vercel, that should be yarn Vercel, and then the path to our project. In this case, this is build, right? The build folder. It's not the build command, it's the build folder. And then it says set up and deploy this build folder, which in my case, I want to say yes. And then I would choose my own personal account. I'm going to say no, and we can just say test build project. And I misspelled that, but anyway. So because it's already inside this folder, I'm just going to keep it as it is. That means it is inside the build folder already. So right now you can see that it says me that, hey, do you want to override any settings? I'm just gonna go with the default, that is no, and it starts deploying the basic setup with the basic instructions. Okay, so over here you can see it created a .vercel folder which has a project.json inside it, right? And it has a readme over here as well. Now this is all fun and games, but there are a couple of problems here. The first problem is that all of this prompting and setup which we did over here, we cannot do that on GitHub Actions. Why? Because we don't have an interactive terminal, right? Neither do we want to. Nobody wants to go to that action every single time and hit enter a bunch of times. That means this project should automatically be deployed every single time, right, when we push. So what we can do is we can create a small little script which automatically runs, and it does take no input from the user, and it automatically deploys to Vercel, right? So in order to do that, we're going to be taking a look at how we can create such a script inside our package.json. So that's pretty much it for this video. I'm going to continue in the next one where we will discuss this. Hey everyone, welcome back. And in this one, we'll be discussing about how we can deploy with Vercel without any intermediary requirement of this keyboard or anything, right? So before we actually go ahead and do that, let me just go ahead and open and verify that our project is in fact deployed on Vercel. And you can see that we have a nice test build project.vercel.app, which loads our Snowpack production build just like we would expect it to, right? Super fast, on the edge, and deployed just like that. Now, if you take a look at the Vercel project deployment pipeline, we had 3 requirements. And in this little series, I'm just discussing about Vercel, but this particular thing basically applies to more or less anything which provider you're deploying, whether that's on an EC2 SSH machine or whether that's on something else. You can see in the project, we have the organization ID, the project ID, and the access token. Remember that token which I copied pasted in the CLI? That is the access token. So we need these 3 things supplied to the Vercel CLI. And thankfully enough, Vercel CLI does allow us to pick these from the commands itself. So I'm going to say something like deploy. And this command over here would actually run Vercel, which is also, you can also call it with Vercel or VC, right? And this command over here, this should deploy our app to production. So that is flag number 1. The flag number 2 is what is the token which we have, right? And this token over here was the value which I copied. So to get that value again, I'm just going to go ahead and copy this and paste it right here. So this is our token over here, which I would obviously remove once this video is done, so that you don't deploy on my environment. But this token is the most important part. The next two things, that is the Vercel organization ID and the project ID, they actually come from the environment, right? So Vercel needs those two values from the environment, and it's not up to me. It's the way the Vercel CLI is built. So it's not something I have configured. So for the environment part, now this is interesting, because for the environment part, first of all, let's just create a step for deploying the project. I'm going to go ahead and say run, and I'm going to make this multi-line. Remember, we can do that. And I can just start here as well, or I can give it a tab. It doesn't matter. For the run part, I'm going to first of all go inside the build folder, because we know it is ready. Then inside the build folder, or actually, let's not do that at all. Let's just run yarn deploy directly. And for that, I think we don't even need a new line, because we can include the build folder command just right here, right? Now, this command is fine, but it's still missing the env, the environment support, right? So in GitHub, what you can do is specify another key called env over here, and you can start mentioning the environment variables which you want in this step, right, to be available in this particular step. And this is again an object. It's not a list or anything. So what we need to specify for Vercel is the Vercel organization and the project ID. So I'm going to copy the organization ID, and I'm going to go ahead and paste it right here with the Vercel organization ID. And the second value which we need is Vercel project ID, right? And the project ID over here was this particular thing. Now we have all the necessary parts in this particular deployment pipeline. We have the organization and project ID. That means we can just completely get rid of the build folder, which also contained the Vercel folder. We don't need this anymore. We have the token with us in the deploy command, and we have the build steps running just fine, right? So let's just go ahead and try to push this to the build pipeline, and let's see how that works. So I'm going to go ahead and commit this Vercel build test and push it over there. So now if I go ahead and take a look at this GitHub repository, you're going to see the action which is running right now should also build and try to deploy your project on Vercel once it's done with the node modules part. All right, I think we have an error here that this is not a option. So I guess this CLI flag is called prod and not production, and we can just test it once by saying yarn deploy ourselves, and of course this folder is not found. So anyway, let's just go ahead and give it a bug fix message and push it to GitHub for it to deploy, and we're gonna be just sitting back here just seeing if GitHub is able to deploy this or not. All right, so in this case you can see that Vercel CLI is kind of misbehaving, and I don't understand why or when they changed the behavior where they would not read the organization and project ID from the CLI. So we're gonna do a little bit of improvisation. I'm gonna run yarn build again, and we're gonna deploy it from the build folder directly, and we can construct the Vercel folder on the fly, which is also something interesting you can do with, because you can pretty much script everything in the Vercel CLI. So let me just go ahead and say nope to this, or yarn Vercel. Actually, we don't need to deploy that. We need to deploy yarn Vercel build. And this is also something which we, I guess, missed in the package.json, that we don't need to cd into that. We need to build like this. Yes, Mehul Mohan. Yes, link to the existing project, and the project name for this was the project name, test build project over here. And let us see if it creates a Vercel folder over here. And if we go to the build folder, you can see we have a Vercel folder, and right here we have the project.json with us, right? Which is basically the same thing. So what we have to do now is add a build step where over here, before it deploys the project, it sets the Vercel env. So we can say something like run, which is a multi-line command now. And I want to say, I want to go into the build folder. I want to make the directory, which is .vercel. I want to touch the project.json file, and I want to echo this JSON string, which I have, into project.json, right? And this is just a hack, right, for deploying this thing, because Vercel, for some reason, Vercel CLI is misbehaving right now. So this is all we can do at the moment. Now, what we can do next is pretty much add, commit, improvise Vercel deployment. And we have already changed the package.json command as well. So that should be fine. And I can just push it and let's see what happens. And of course, Vercel has to give one last error to us because we are missing confirm flag over here, which should skip all these automated questions. Let's do one final build and see. And there is another error where it says that the token is not valid, and today is probably an error day. So I'm going to go ahead inside Vercel dashboard and create a token manually. My Vercel token, create this token. I'm going to copy this and use this instead. And there is one mistake we have to fix, is that we have to go inside the Vercel folder after creating it, so that this is actually inside that particular file, right? So once we do that, we can do a final fix, and let's wait for it to deploy. And as you can see, Vercel has started deploying on the test build project project folder, which was our typo for this particular URL. And once it deploys, you can see that it's ready. And of course, we did not make any change, but when you make any change on this text now, it will automatically reflect. So this right now is an example of a fully functional deployment pipeline over here from GitHub Actions. You just have to make some changes, push your code, and it will automatically deploy it. But it has some obvious serious flaws, like exposing all these secrets like this, right? So we still need to fix that, but we'll take a look at how we fix that in the next video. That is all for this one. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this video, I want to discuss a very interesting part about GitHub, that is known as GitHub secrets. Now, GitHub knows that a lot of times we will need sensitive environments and sensitive values to work with. In this case, the three sensitive values we have is the project ID, organization ID, and those two are not so much sensitive as well compared to this one thing, which is the token ID, right? Which is very, very sensitive. So the way we approach these sort of things in GitHub Actions, especially with something which is like a public project over here, is that you go ahead and convert these things into secrets on GitHub. Now, to do that, what you should do is go ahead inside the settings on GitHub in your particular repository and go to this particular manage access. And let me actually, now I think about this, I should have made this repository private, because anyone at the time of watching this video, creating this video, could have just gone into the repository and copied my Vercel token and remove all those projects which I have. So hopefully nobody did that yet, and that was my bad on my side. But anyway, so now the repository is private. At least we are sure that nobody's messing around. Now what I can do is go ahead inside settings and inside secrets over there. And you see over here, this is a place where GitHub allows us to add secrets to our repositories. Now, a secret is basically, you can think about this as a kind of a variable, but this is encrypted. That means this is not visible in the logs, and this is not visible to anyone who's using your code as well, right? So I can say something like Vercel project ID, right? This could be named anything, and this goes as a secret. Now you can never see the secret again. You can only overwrite it, but never really see it. And then Vercel organization ID, and there we go. We have the two secrets now, and the third one is my Vercel token, right? In this case, this token would be this particular thing. And of course, once you add secrets, you should obviously just refresh all the values so that, somebody just does not go into Git history and check out what you have done. Now, in order to access these secrets, you first have to bring them into your runner's environment, right? These secrets are not just available into the environment right away. So in order to bring these secrets into the environment of your YAML file, you have to do two things. The first thing, like we already did a little bit earlier, that is, you have to, in case of the deployment part, we want to do this, you have to add an env block. And the second thing is you have to specify what the secret name was initially in the GitHub secrets panel as well. So in this case, I want to say that, hey, I want to get this back as a Vercel project ID as the env name. And what this value was from secrets dot the same thing, right? Why? Because this thing right here should actually match this thing over here. This thing could be anything, right? Whatever this is the name of the environment variable. In this case, I'm also keeping the same, but this has to match the secret of the GitHub, right? Similarly for token, we can get the token like this, secrets.Vercel token, and then secrets.Vercel organization ID. This over here, this secrets variable is automatically filled by GitHub. So you don't have to do anything over here. But the moment you do that in an env block, now these three environment variables are available, right? And of course, you would want to do this one block above, that is in this particular job itself. Now, when you specify the environment variables on a job itself, then of course they are available for all the steps. When you specify it within a step itself, then it is only available for that particular step, right? So we want to do a little bit of change over here. I want to escape these codes real quick like this. And I'm going to say over here, this is Vercel project ID, right? And this over here is Vercel organization ID, I guess. Yep, there we go. And now we are filling this from the environment. And finally, because this yarn deploy is also running in a step, which is controlled by GitHub action, we can go ahead and use the Vercel token variable directly as a bash variable, right? Because now this is an environment. So this also secures this now secures all of our environment variables as well. So I can go ahead and add, commit, and moved to secrets. And I can say git push origin master. And this should be more than enough to protect our stuff. And as you can see over here, whenever GitHub tries to echo out a secret variable, it automatically masks it in the input. That means if you use echo Vercel project ID or anything over here, GitHub would not show it in the logs, right? It is still technically, obviously possible that you echo it to a file and then perform an HTTP request and extract it out somehow. Sure, that's possible. Otherwise, how the hell would the command itself use it? But for the most part, the logging part is protected, right? You cannot just log a secret and be done with it. So yep, you can see the builds are still reflected on the main project itself. And now we have a fully functional, secure deployment pipeline, where if I say something like hello from Codedam, this is so awesome, all I have to do now is add the change and push it to my GitHub pipeline, and this would deploy my project. It'll build it, it'll minify it, it'll do all sorts of amazing stuff on the Vercel CLI itself, on the GitHub action itself, and deploy it on this particular URL. Test build project, which is our typo. You can see right now it's not reflecting because it's not built yet, but this would be built soon, and then it'll basically be visible on the screen. All right, so once built, you can go back to the page, hit refresh, and now you can see that it reflects your production build, and it's on Vercel deployed app, on the edge, super fast, super scalable, all the good stuff, with a good, nice deployment pipeline setup as well. So yep, that's pretty much it for this video. Hopefully you were able to follow along, and this video is deliberately, this whole series with Vercel and everything is deliberately done with the Vercel CLI. Otherwise there was a Vercel action as well, just so you know about environment variables and all this hacky stuff and all that stuff. So this is just a way to learn ideally you should probably be using some easier solution like Vercel action directly, or even just using Vercel runner if you want. But yeah, hopefully this teaches you a bit about how to work with GitHub Actions, which was the purpose of this series. So yep, that's pretty much it for this one. I'm gonna see you in the next video really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how you can create dependent jobs inside of your workflow. Now this is interesting because a lot of times when you start a second job, you don't necessarily want to run it in parallel, right? For example, this might be a build app, this might be a test app, and you cannot really test a web app until it is built and deployed, right? Then that is the point where you will run the Cypress end-to-end test and all that stuff. So in this case, if I also specify I run something as Ubuntu latest, and in this video, let's just keep the steps as very simple. I'm just gonna say run echo YOLO, something like that. What I want is that this YOLO waits until the build is complete, right? And the way you can create these dependent jobs is by using something known as needs. Now this needs key is a special key for GitHub, which says that, hey, if I specify this build app over here, it's gonna wait for this particular job right here to finish. So now if I deploy this dependent job and push it on GitHub, you're gonna see that if I go back to GitHub, it's gonna wait for us. It's gonna wait for our build to complete, and then it goes to the test app. And you can see this with this little link which GitHub creates, right? Earlier, you knew that when we created this job, both of them appeared here parallelly and they were executing. Right here, you can see this test app is actually, a little dimmed, right? And it will only become active the moment this, the first job actually succeeds, right? Or not exactly succeeds, but it completes. And succeeds is also a correct word, because if it fails, then the next step would not run, right? Which is the test app job. You can see now the moment it completes, it jumps to the test app version now, and now you see a dependent job, and it runs the YOLO command, and that's pretty much it. Now this is of course fun, but how do you get the data from previous job to the next job? Because that is pretty much, you would be doing a lot of times. So there's a way to do that, and we're going to discuss about that, how you can get some information from between the jobs in the next video. That is all for this one. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this video, we're going to be taking a look at how you can pass information between two jobs. Now this becomes super important and super interesting, because in this case, for example, we want our second job to run end-to-end tests, and the first job just builds and deploys, right? Now the reason you need to pass information between them in a special way is because if you take a look, all the different jobs run in completely separate environments. You can see it starts from scratch. It does not share the file system or the underlying anything, variables or anything as well from the previous job, from the previous build, right? So this becomes really important that you understand why we need to transfer this information in a special way. Now, the way you do that is using a special syntax. We echo a special variable we call as, we're going to say set output. We're going to set this name in form of a pair, right? So in this case, let's say if I want to send this link or send some information, send some text over here, and this text should be hello world from build job, right? A simple enough text string. Now, the way I have exposed this is that there is this variable text in this particular job, which can be read by any other job which needs it. This step is also important. So if I copy this text and mark this as a export kind of thing, now again, we know that YAML is not strictly speaking a language, but you can still use these features because GitHub provides them out of the box. You can add an outputs key over here and say that, hey, my text variable would be a variable which would be available from steps dot, and then you have to add the ID of the step which you want where this particular variable is exported. In this case, we do not have an ID on this. So we're going to say something like id as final step, or let's just say finished, something like that. And then steps.finished, and then the name of your variable, right, in the output section. So this is text. So what we are essentially saying over here is that the output, we are setting the output variable of text to this particular string job, and we are marking that, hey, this particular text is the output of this whole job itself, this build app itself. Now you can consume this particular output inside of your, basically in your next job, which needs this particular thing. And the way you do that is with another special syntax of GitHub, just like we used in the secrets part. So I can say my job output as needs, remember this needs thing which we did, dot build app dot, and let me just go ahead and mark this as build app, because the dashes makes me a little nervous, because that's not how you usually write in programming languages. Build app, and we will also need to change this to build app, then needs.build app dot outputs and dot text. Why? Because outputs.text is the property which gets outputted, right? And once you do that, and once you try to use this right here, it should just spit out this particular string from the last job. So now if I go ahead and say dependent jobs with data sharing, then this should pretty much be everything you would probably need in most of the cases. This is all you would need to work with GitHub Actions in general, right? You have a build step, you have a test step. You can use this area to not just send a static string, but something like the dynamic deployed URL of the staging or the preview. Write it here, read it from here, and send it to your Cypress runner or something. And why stop here? After test app, for example, you can have another step which says like the email the deployment status, where you get an email from GitHub. I mean, you by default also get emails from GitHub on the default action status, but yeah, I mean, you can, why not just add it as a step? So you can see our build app step is completed. Now we are waiting on the test app part. And right here, if I take a look, you can see it says me hello world from build job, which is exactly what we wrote as the string over here. So yep, that's pretty much it for dependent jobs with data sharing. Super important stuff for building your custom pipelines. That is all for this one. I'm gonna see you in the next video really soon. Hey everyone, welcome back. And in this video, let's just go ahead and set up a Git repository in this source code first, because that is what will allow us to also then set up a GitHub action. So I'm going to go ahead and open a second terminal over here, and I'm going to start writing git init, right? You know all of this from your from basically your GitHub course on Codedam. And I'm going to just initialize, I'm just going to say git remote add origin get, or I'm just going to go ahead and create a repository first. So new repository, I'm going to say, let's say this is test GitHub Actions, or maybe like GitHub Actions Codedam course, something like that. I can make it public, and I'm just going to create this. Now once I create this, I'm going to just use the HTTPS version. I'm going to say git remote add origin and paste this thing. Now when I do git remote you're going to see that that particular origin is added. Now, one thing we are still missing is the git ignore file over here, so that we can just add node modules and everything. And yep, that should be it. And if I say initial commit, okay, we need to also set up git here real quick. All right, so once that is done, we can say git commit initial commit over here. And I can now just say git push origin master. And apparently GitHub has removed the support for password-based authentication. So what we can do is go back and create in the GitHub settings apps, create a personal access token just for this use case. And I'm gonna of course remove this just tomorrow, so that it's not misused, obviously. I'm just going to say this is GitHub Actions token, right? Make sure you select the repo access so that it is able to access all your repositories. Copy this token right here and remove origin because we need to add it back. So I'm going to say git remote add origin, my token @github.com, mayhole mpt GitHub Actions codedam course, and hit enter. Now I can go ahead and push it to the GitHub, right? Now the moment I do that, you're going to see that if I copy this repository URL and paste it over here, you're going to see that it pushes our code to GitHub, which is awesome. But now we need to set up certain GitHub actions, right? Now the way GitHub works is that it needs a folder called .github. It's not Git. You can see the Git folder is already here. We created a .github folder, right? Now this particular folder, whenever this is present, GitHub would try to see what kind of workflows this folder contains, right? So I'm just gonna go ahead and create another folder inside this called workflows, right? And when we create that folder, any YAML file which is present inside this particular folder would automatically be marked as a GitHub action. Now, what do I mean by that? Let's say I create a YAML file test.yaml, right? It could be test.yml. And if I go ahead and open this, you can see that we get a YAML file over here, and I can just go ahead and write some crap right here. Let's not worry about this for now. But what this essentially means is that this particular file is now a GitHub action. And now let me go back a couple of directories and just push it again with a test YAML added. And I'm going to say git push origin master. Okay, so we do not have a workflow scope in the access token. So this might not be a problem if you actually go ahead and just use SSH based authentication. In my case, it is a problem because I am using an access token, but you know how to set up an SSH based authentication as well. I would not recommend doing that on the codedam playground until and unless we secure all your credentials, not just the source code. So maybe when you create a new token, let's say this is GitHub Actions token 2, you also give it the access of the workflow over here. So once you create this token, copy this again, git remote remove origin, git remote, basically do the same thing. And then I'm going to attempt to push on master branch again. And this time this works because now it is able to create that workflow for us. If I go ahead inside this, take a look, you're going to see this .github workflows is now created. And if I go to this actions tab over here in my repository, you're going to see we see something. Test YAML added with the cross because obviously we did not write anything meaningful inside this particular file, but you can see something happened, right? Now this is what the workflow is all about. You create a workflow with a file, a YAML file inside GitHub workflows folder, and it just gets picked up by GitHub automatically, right? No configuration, nothing needed, no toggles, anything like that. So a lot of work which we'll be doing would be in this YAML file from this point onwards. And I hope you understood so far what we did. We just created a repository, we pushed it on GitHub, we created this folder structure, and GitHub automatically picks it, right? This is all magic of GitHub. It's not the magic of Git as per se. So yep, that's pretty much it for this video. I'm going to see you in the next one really soon.